доклад на английском языке. Под флагом можно забрать устройство, которое позволит вам слушать доклад по-русски. Я понимаю, что у всех в резюме написано, что вы говорите без акцента, что идеальный английский там и так далее. Но вот для полного user experience лучше возьмите переводчика, пусть в одно ухо вам бубнит. И мы начнем через минуточку, потому что сколько-то секунд нужно, чтобы заполучить устройство. Вот, возьмите устройство для синхронного перевода, и мы начнем.
Make sure you pick yours up right away, and we are getting started soon.
Будем.
Starting in 1 minute.
Друзья, великолепный день.
It's an awesome day today, isn't it, dear friends?
Котики получают устройство для синхронного перевода.
As you are still picking up
поиграть. So how long did it take you to fly in from New York? How many flights did you have?
2 flights.
2 flights.
That was crazy. Like
That's too simple.
13 hours flight to Qatar, then Qatar to Moscow, 25 hours in total, 5, 6 coffee, and yeah, caffeine just like took me over, made me travel so much. And that was like fine.
It's all right. We have prepared, because yesterday the weather was awful.
Oh yeah.
So we've worked on the weather all time.
That's good.
By the way, have you developed a skill of giving a talk without a presentation?
I have, but like we need something because it's a talk on visuals, and we need some visuals for that.
That's all right. We are working on them as hard as we can. It's all right. It's the time where you check your phone for maybe working dialogues or maybe your mother texting, whatever.
Yeah, I think the time zone's going to be different. They must be chilling by now, evening tea. And here I am, just like trying to fix the screen and just like trying to speak up on WebAssembly.
Коллеги, а можете на пальцах показать, через сколько у нас будет преза? My favorite story happened in Cyprus, where like the second person from the president who works with the digital community was about to give a talk. And so he said, you know, I've been a programmer for years, so I knew there would be technological problems, so I decided to go without a presentation. And so he had like an inch of A4 papers with his talk, and he was just reading it, you know.
Yeah, that's how professors work.
Sweet.
Already, by the time you're just like fixing this thing, give me a raise of hand, like how many people here know about WebAssembly before? Perfect, I see a couple of them, that sounds good.
Say 7. At least.
I hope like by the end of this talk, like at least 100% of everyone knows what WebAssembly is. And how many of you ever worked with something like a Pygame or just like created 2D games in Python? I think I've got more hands now. Cool, so yeah, that sounds pretty interesting. And yeah, that's the 2 questions I have got.
What is your background? How did you start writing code?
Oh, so I started writing code when I was like 12 or 13. Just
12.
Like 12, like first thing I did was like plain HTML websites. That was the first thing I used to do, and I used to have this like colorful sections and divisions, and I used to be like, oh, this is cool, dude. And then I used to see my brother just like, he was like in university giving me his textbook, like, dude, just like go for it. I'm like, yeah, this is cool shit, like, it's like fun. And yeah, then everything just like piling up, pieces by pieces, got into web development, got into data science, got into AI, got into security for a bit, and eventually became a climate guy. So I plant trees now, apart from doing my technical stuff. So it's been a hell of a journey, and I'm enjoying it.
Wow. Did you have a dream to work at like a big tech, or did you start with gaming?
Oh no, so currently I'm trying to build my own company. So I hope it works out, so I don't have to work for someone else. And if that doesn't work out, then
You want to work for them, you want to become them.
that's very apt, I would say. That's like
That sounds like a plan.
that sounds like a plan, yeah.
You know, now I'm happy that I did study English at school and then in college, because otherwise we would be like, you know, looking at each other right now.
Yeah, we would have just like, you know, used the sign language somehow and figure it out.
By the way, for the previous talk, we had a discussion on all the tools that are working from the cloud. So you're not updating any hardware or any plugins that you have for your work on your computer and like at your desk. But there are lots of stuff that's working from the cloud already. Where are you in this situation? Are you the hardware guy and the plugins guy, or the cloud guy?
I'm the cloud guy. It's easy now for a small team. Yeah, you can't just like plug in, plug off, take care of the servers, take care of my code, take care of the bugs, and take care of AI. I think the cloud is like a much better option. It's cheaper as well sometimes. But yeah, we have been in both situations. But now I feel like cloud is like a better solution for me, maybe not for everyone else.
Okay, when your team says 1,000 people,
Is it still going to be cloud-based, or
I think
maybe something
at
will
that
change?
point, I think we're going to be switching up. We're going to be taking up our own servers. It's going to be a hardware thing. Because at that scale, I think it's much easier to manage your own dependencies rather than just like relying on some other big company to have manage all those things. And it's more efficient. You can just like scale it as soon as possible, and if something breaks, you are responsible. And you don't just like blame, go to AWS and say like, hey guys, what's up? What's happening to my cloud servers? So I think those are the things which are interesting. And it's still not fixed.
Oh, it's all right.
We got time. We got time.
Yeah, it's a question of SLA, yes. But one final question. So I see that there's the technological community where hundreds of people are learning to write code. The code is working right. We're testing it. We're sending it into production. But then it comes to a conference. Like yesterday, you were just a code writer, and today you got to be a rock star, on the stage.
True.
What are your steps on becoming a speaker?
I think if you want to become a speaker, just like go attend some meetups. That's the first thing. See how people are speaking, and just like take up a single task, like go for conferences, volunteer for conferences, and yeah, just don't be shy. Just like go up and speak about something. I mean, everyone has something to say, because I'm talking about WebAssembly. Maybe volunteer is going to talk about WebAssembly. It's going to be two different perspectives, and perspective matters, not just the content. So I think those are the few key skills. But I mean, there's no like skill when you're speaking. It's just like you're talking about something. It's not something you're gonna be not finding on the internet. It's definitely there. But like you wanna listen to us so that like you wanna know my own perspective and how I'm gonna just like convey the message to you. And expect like by the end of the talk, everyone understands something and learn something new.
Yeah, thanks for that. I think maybe I should offer you to sit down, maybe drink your water, and just wait for a couple of minutes, and we'll just sit quietly for a couple of minutes. What do you say?
Maybe I'll just like interact with everyone. So, how many of you guys are here who doesn't do a typical data science or a web development kind of a job, like not working with Django, Flask, or NumPy and all, but doing something new up with Python? Would like to like speak up or something? Would love to like talk about these things. Or maybe working with climate, geospatial information, data, and all these things. I saw a couple of hands, but like no one's. Is that mic working?
Most of the guys that raise their hands work for the company that is giving this festival to the community.
Okay.
Yeah, so these are the guys who are home.
All right.
Any more questions? Do you like blues or rock and roll? Jazz?
Jazz is good. Jazz is good. I mean, I spent a lot of time in Berlin, so I'm also like a deep house kind of a guy, just like chilling with the music, dancing, sometimes techno, hardcore. But every week, I can just like listen to that and just like stay awake for like 24 hours and just like dance on the floor.
And my final question, I hope. Have you experienced Moscow yet? Have you seen anything?
Yeah, I saw a couple of things yesterday evening. I mean, I flew in yesterday afternoon at like 4 o'clock. I got a chance to go across the, I don't know if you call it a river. Is it the Spree? Is it a river? The Moscow has this river, like next to the stadium?
Yes, the Thames. Yes.
Okay, I thought that's a Spree. So in Europe, we mostly have these like small passages. Or in Amsterdam, you have like sprees or canals where people are just like taking up their boats. Alrighty.
Nice. And this spot is known for best concerts. So the stadium over here, we compare it to Wembley, to Wembley Stadium.
Right.
Because if you're a rock star, you want to perform here. So there was a concert of Metallica I came here for. And now you can tell people that you were at Moscow. You were in Moscow.
Absolutely.
And you performed at Luzhniki Stadium, right after Metallica.
That sounds fun.
Maybe now is the time for you to sit down and drink your water. Just stop the small talk.
Okay.
And probably as soon as those guys will sit down, we will start our talk. Now, we'll be the sponsors of minutes of quiet time. I'm so sorry for what's happening.
That's fine. I mean, I've done like quite a lot of like hands-on sessions, and things break. Unexpected things happen. Like your code stopped working suddenly. You're just like running a collab. Once I was just like running a collab, and this night before, they literally changed the version. They deployed a new version, and by mistake, I pip installed the latest version, and the entire tutorial was screwed. Then we have to go back and depreciate the older version, and then give the talk. That was unexplainable. Yeah, that was a fun thing to debug, live debugging. That's what they are doing right now.
I hope they're not asking ChatGPT how to fix the thing and just know how to do it.
I mean, there was no ChatGPT at that point, so I wish.
To present it, but rather I'd ask about using WASM in websites as a powering point. Like, for example, my company uses Blazor WASM.
PyScript is like the interesting project you will see. The most interesting Anaconda people have been working on it day by day. And Pyrdite in general has been the backbone of the entire WASM, like the infrastructure. And when you see like the use cases are just like going wild. So it's just like has become the mainstream thing. Like companies are still adopting it. And alrighty. Oh, it's working.
Yeah.
No, they're clapping because you're beautiful and smart. Yes.
Oh, that's also good, Valentin. Thank you. So companies are adopting. We are also like we're not using GIF for gaming specifically. We are using it for geospatial data because we have so much of data coming in. And so these like, when you work with like GCM, global fabric models, the data is in arrays, and arrays are like so big, and sometimes they even close up to petabytes of data. And then we use it to ZAR, and then when you're just like doing some sort of a visualization on the browser, generally, if you just like load this much of a heavy specific file on the browser, it starts stalling. But like when you make it using WebAssembly, using a C-native kind of interpreter in between, things go very smoothly. So that's another use case I can tell you. Then there are companies working. A lot of REST tools have been just like building up, not directly Python, but like it doesn't matter. It's just a WebAssembly ecosystem. For rendering, for 3D visuals, for mathematical computation, even machine learning, you can now run on. We will be talking about like how we'll be running those computational models and machine learning code now on the browser with WebAssembly. So yeah, so I think it's not like it's getting to die. It's just like it's going up.
So it's like we're very early in the stage, but a lot of these companies are just like doing a lot of things, especially a company in the UK, I think it's called Fermion. So Fermion has a tool called Spin, and Spin does serverless AI. So now you don't have to, now with the serverless AI, you can, instead of running your machine learning models on the servers or the cloud, you can simply call the SDK, which is running in the browser with Rust and WebAssembly, and it's blazingly fast.
Thank you very much.
Alrighty.
That was beautiful. Let's give this thing a fresh start.
Yes.
Давайте поаплодируем техникам. Ребята, спасибо. Спасибо.
Let's hear it for the technical team. Thank you, guys. Thank you. You made it happen.
Страна победителей. Да.
The country of victors.
На сцене. CEO Vivid Climate.
CEO Vivid Climate.
Панды! У-ху-ху!
Niraj Pandey.
We are at Positive Hack Days. Thank you so much for joining in. This is From Desktop to Browser, crafting browser-native game with WebAssembly. And I'm Niraj Pandey. So I'm not a typical security guy. You must be thinking, why there's no security guy? I'm a climate guy. What I do is I plant trees. I also, not just plant trees, we work with enterprises, crunching numbers, deploying our own AI models, geospatial data, model downscaling and everything. But I am also a generative artist. I have been working with a lot of these like new media arts, NFTs at a point now, NFTs are gone. But I've been just like doing a lot of these generative art and stuff. And apart from it, I'm a Pythonist. I go to conferences, I talk about Python. I also help newcomers come up to these conferences and also contribute to like upcoming events all across the globe. So coming back to the topic, this is going to be the agenda. We're going to be talking about like a high, not a very high overview, but like a very brief overview of how WebAssembly works. What are the challenges in bringing the desktop games to the web? So Pygame basics for those who don't know what Pygame is. And then we're going to be introducing pygbag, which is going to be something similar to how a package manager works, but it's mostly a package distribution tool. And then we'll see like how we can convert a Pygame game to the web version. And hopefully we'll have time for QAs. Alrighty, so beginning with WASM. So if you go with the definition says like WebAssembly is a binary instruction format for a stack-based virtual machine designed as a portable target for high-performing web applications. Trust me, it took me a week to understand what this means. So what they actually mean is you're writing a code in any specific language, be it Python, be it Rust, be it C. But until now, before WebAssembly, all those V8-based engines or the browsers like Chrome and Safari can't make anything work on the browser because browser needs JavaScript code or something which those machine translation think or the binary code they can understand because you can't directly work with the web APIs or IO operations on the browser. And what WebAssembly gives you, it takes your code, it interprets it, it compiles it, and it changes to a machine translation, which is a universal code. And what happens now is like you have a binary set of instructions. You can use it. You can use it on Linux, Mac, Windows, your own operating system, whatever it is, and run it on your browsers. So anything you were making it initially or making running on C or Rust or something, and you were concerned about like how it will be on the browser, now you can simply take those code, compile them, using we'll see like how we can use those like toolkits of those like OnScriptum and all, and get those binary instructions and make it work on the browser. And the best thing is like the speed you get, the performance you get, it's going to be very close to or maybe very exactly the same as the native code you're going to be writing in the Rust and everything. So to begin with, to understand how WASM or the WebAssembly's execution flow works, we'll try to contrast it with the Python thing, because we are at Python Day. That's the language we know. So you start with a Python source code. You have a Python source code. You write it. This is the most human-readable code we write. And it goes to the Python interpreter. What happens? It's like it goes for compilation. And during this process, what happens, it converts your Python code into a Python bytecode. So for those who don't understand Python bytecode, it's not the final machine code like those bits and bytes. It's an intermediate representation of your file, like a set of instructions. You can think of it as Have you guys worked with languages which operating system understand, like assembly? So where you're specifically saying like, hey, move A, which is the variable, to 0 and all those things. And the bytecode is then stored as two different files, because there's a myth, like everyone thinks like, hey, the Python bytecode is being stored as a PyC file, as in the cache, which is not true. Because only the modules you're importing, only the files you're gonna be re-importing or just like running it again and again is gonna be stored in the PyC modules in the __ pycache folders. And every other logic, it's gonna be at runtime instantly in the memory. So it's not going to be stored anywhere. It's just like those modules will be there in the PyC file. And we take those two files and send it to the PVM, the Python virtual machine, which is the brain behind the entire interpreter. It takes those instructions and say, OK, just like you go and you give instructions to a chef, like, hey, you need to put like some first ingredient, the second ingredient, and so on. In the same similar manner, it just like take those instructions and deploy them one by one, and eventually it produces the program output, which you see. Pretty simple. Similarly, when you're working on the WebAssembly execution code, we have the same format. You write your code. Here, the thing is like you don't have to be writing the code in Python. You can write it in any single specific language. Goes to the compilation, goes to the WASM ecosystem, the interpreter, and it first creates those WASM bytecode. This bytecode is not the one which is very similar to what Python makes. So what happens is like WASM takes this bytecode, converts them into a WASM module file. So what a .wasm file is like something which is very similar to how the Python bytecodes work and how those assembly kind of instructions are. And once this is done, it goes to instantiation. It's sent to the WASM runtime, which behaves like the same, like the Python virtual machine. And here the only difference is like, here the memory is not like what you have in Python. Here the memory is a linear memory. So what do we mean by linear memory is like it's a contiguous block of array, and it's not a static kind of a file. It doesn't have like garbage collection happening over there. If initially WebAssembly deploys a 16 megabyte of like initial memory, and somehow your computation part requires 40 megabits in like the next minute, it will just like scale automatically. So everything which is there in the WASM runtime, all the WASM files just like gets stored in the WASM memory. All the I/O operations are happening there. We'll see in the next slide like how these I/O operations can eventually talk to your browser, and those I/O operations can be connecting or talking to, like interoperability will be happening with the web APIs. And once this is done, it's then executed and your program is run. And this program output could be anything, whatever you want to run, be it on your a browser environment or any runtime you're working on. So it could be Pyodide, it could be on Scriptum, it could be anything. Alrighty, sorry. So the only difference now is like, what happens when you're working with the web? Same thing, write the source code, compiles into WASM bytecode, stored as a WASM file, instantiate into the WASM runtime. But now what happens is, oh, I forgot to tell you one thing. With the incoming of WebAssembly, it does not mean we don't need JavaScript anymore. Because it was my concern also, like in the beginning, like, hey, why do we need WebAssembly? Why do we need JavaScript anymore? Because everything is being done over here. Because still, the browser don't understand anything apart from those JavaScript, because it needs JavaScript to interact with the DOM and manipulate your the web APIs. So what happens now is like your WASM file can directly load the JavaScript, which can now talk to the DOM or the network or the web APIs you're working on. And you have a linear memory which is being allocated at runtime, can scale and everything. I/O operations are happening. But now everything is running in a sandbox environment. So why we need a sandbox environment is for the security purposes. So let's say I'm running a bunch of Python code on the browser. I don't want my Python code to have access to any other I/O operations the JavaScript or the browser is doing. So everything which runs in WebAssembly is in the sandbox, so that it doesn't have access to the other resources which are happening on the browser and everything. And that's it. Everything is done, and we get the output. Very simple. I hope it's very simple by now. Cool. This was supposed to be a video, but like somehow it's a PDF file, so I'll still try to understand, make you understand this thing. So why execution flow matters? So these were the particle flow, like thousands of particles dropping from top to bottom, and a lot of like, they're just like falling under gravity. So we have a simulation, or you can say a stress test. If you're making games, you know like things are moving so rapidly at so short interval of time. So if things are working, if things are falling, it's just like happening. Millions of pixels are just like changing within a second. So the first thing, the first image was from a Pygame. It's all running on Pygame. So every example you're going to be seeing is going to be on Pygame and something on the normal Pyrdite. So what is happening here is like those objects are falling, and the same thing is working on the browser using WebAssembly. And when we tested like how much time and everything, the metrics were, the performance index, we saw like the average frame time was 6.31 millisecond, and when it was running on WASM, it reduced by half. Similarly, the particle updates were happening at 0.16 million particles a second, and when we just like started running it on WASM on the browser, the speed increased to twice. And the third thing is like currently the CPU usage was being taken up to 95%, and when we switched to WASM, it dropped by half. So we clearly saw like there has been a drastic change of performance when you are using WebAssembly, because it's much, much faster. And one of the main concern you might be thinking, why is this like suddenly drop, is because of the garbage collection. Because Python keeps the garbage collector stops, clears up those spaces, and then start again. So this takes a lot of like memory in the process. So the benefits, it's high performant. You can make any kind of high-intensive game. It can be a little complicated at times, but like it's going to do the job. You're going to get the near native speed. Portability, it can work on almost all the browsers you can think of. All the modern browsers, I would say. Security purposes, it minimizes the risk of malicious code because it works in a sandbox environment. Nothing can come in, nothing can go out. And interoperability, which means it can have a possible combination for web application, which we're going to see. So like now you can make use of WASM for the performance and make use of JavaScript for manipulating the DOM or your web UI components. So how do we combine WASM with Python? It's just an overview of what we just like saw. Like Python code is converted to WebAssembly into a WASM module, then it just like loads this thing in the browser. JavaScript interacts with both Python and WASM at runtime, and there are different kinds of runtime. So one of the most famous one, which Pygame the Pygame don't use, because Pygame and both uses unscripted behind the scenes. So any kind of LLVM we use can be just like compiled using unscripted. But Pyrdite is another one which is mostly being used by the scientific community on Python, and you can use it to make visualizations. Maybe you're working with Matplotlib, you are trying to have those like interactive dashboards which you were making before on your local systems or those Jupyter notebooks online. Now you can simply integrate into your websites or whatever you're working on using WebAssembly. So that brings us to Pyrdite. Like, what is Pyrdite now? So Pyrdite is, as I said, like it's like a package manager, but it's not a package manager. It just like packages everything and make it work. So what I mean is, it's basically a port of the C Python interpreter. It takes your code, interprets it, and compiles it to WASM. And it has a support of more than 75 scientific libraries, NumPy, Pandas, and everything, and it uses micropip. So what micropip does is, just like your PyPy, when you just like use your package installer, you can use micropip to install any kind of package from your any kind of pure C Python written package you can install directly using micropip into your environments. And yeah, that's pretty much it. This QR code is somehow wrong, so I just like realized this morning. It's an old QR code, and they have just like updated their link. And if you see on the diagram on the right, this shows like everything. JavaScript is at the core of our thing in the browser. What it does, it interacts with Pyrdite, which already has a pre-interpreted WebAssembly code, which runs on WASM. But what also Pyrdite does, it's also loaded the packages at the same time during your runtime, whenever you're just like running it. And when it does, it compiles those binary files, it goes back and return those data back to the JavaScript, and then you can interact with the web APIs or anything and show it on web browser. So what's happening here is, you're going to see in a bit, is to understand the syntax. We start with like initializing load Pyrdite. That's one of the main thing. And second thing is like you always use asynchronous operations for this because it has to be in alignment with the browser's single-threaded architecture. Otherwise, you don't want anything you're working on your browser to be stalled or to stuck. And the second thing is like you initialize it, you call it like run Python, and you pass it into the string literals, and this will basically return everything back to the browser. So the control is going to go to the Pyrdite interpreter and comes back to Python. Second thing is you can also call functions like, hey, pyrdite.run Python async, import the time, import the modules, give it a go, and just like print it up eventually. And this data will eventually be returned back to the JavaScript, and then you see like how it can be used up. You can also load packages. So let's say we are working on NumPy computation, we are working with matrices, determinants, linear algebraic operations, and everything. We can simply load the package and do some operations. We can also work with JS variables. You can also make sure like anything you are like working on the JavaScript ecosystem or on the DOM can now be run directly with Pyrdite. So you just like set the global variable, set the JS var, and pass the JS value. And the last thing is you call pyrdite.run function. That's a small function, and then you can simply call it from your JavaScript event handler. It could be anything. It could be an event handler. It could be a DOM operation. So let's say let greeting is to pyrdite.globals.get greet function and pass the value Alice, and it's going to return hello Alice. So now we're going to see like how we can have a simple NumPy array. We are calling a function use NumPy. We're initializing the load Pyrdite into the Pyrdite variable in JavaScript, and we're saying like, hey, await load the package, which is going to be NumPy. And we have the result, and in the result variable, we're just like calling the function and saying like, now you have Pyrdite loaded into the runtime, because everything is being loaded at runtime. There's nothing, it's not loaded at runtime, it's being called whenever it's required. We call the array, we call like numpy.array, we pass the variables, we say like, hey, this is the mean, calculate the mean, and return the f-string value back to the browser. And how it works in a HTML environment, or like whenever you're working on the browser, it could be React. It also has like compatibility with React and Vue. So you have those script tags into your browser, you call it, you call the function, you have that async operation, you say like, hey, there's going to be an event handler, get element by ID, which is going to be output. You pass it like loading, and then you say like, oh, now let's start with Pyrdite. Load the package, result, and everything function you're writing in Python has to go up. Has to go in a string literal, and you pass in the function. You say here what you're doing is like we're just like calling a 3x3 random matrix, calling the determinant, and that's it. We're just like finding the determinant of the matrix 3x3, and we just like saving that value into the output field, and output is going to be eventually be updated by the JS DOM. And if this is the same thing like which I just like told you, it combines and executes the Python code in the Pyrdite environment, and Python prints the statements and the errors, and now the errors is not going to be coming into your console, it's into your Python environment. It's going to be coming directly to your browser, just like your normal web applications work. And if you run it, you're going to see like a single click of button will now be doing all your computational tasks which you have been doing before on your systems or your Jupyter notebooks and everything directly on the browser with no compromise on the speed and performance. That brings us to Pygame. So Pygame is one of the oldest libraries in Python since 2000s or something, and it has been a abstraction on the simple directive media SDL. And what SDL is again an abstraction on OpenGL. So it's just like abstraction of abstraction. And there used to be a project called PySDL, which just got stalled. And some cool people just like came in and just like reopened the project and just like started working with Pygame. And what it does is like it gives you those abstractions to the hardware you're working on. So it could be anything like a joystick, keyboard, mouse, anything. So we're going to quickly go over through this because we have only 16 minutes. So what is Pygame? I just told you. It's a cross-platform set of Python modules designed for writing video games. Mostly it's for 2D engines, but you can also make your 3D engines out of it, but you will have to create your own engine in Pygame to render those 3D objects. And it can also be used to render those computer graphics and sound and videos, anything you can think of as a part of the game, built on top of the simple direct media layer, and allows you to make games. So very simple. We'll be saying by the end of this 5 slides, you'll be like, oh, I know Pygame. I'm going to make a game tonight. Key features, you can render images, as we said. You can render sounds, you can play with sounds, you can see collisions happening and just modify those event handlers with the sounds. Even user inputs can be coming in from your anything, it could be your any kind of hardware. It doesn't have to be some specific one on mouse movements, on keyboards and everything. And the last thing is the game loop. Game loop is the backbone for your entire gaming engine, which is it's like a function, it's like a never-ending function unless or until a condition just fails or just condition satisfies, which breaks it and brings it out of the game. So what it does, it updates the state of the game. So if you think of a 2D game before, you used to have Pac-Man and all, you used to have state of where the object is and where the object is going next. So game loop is one of the one which is responsible for doing those things. A couple of slides on how Pygame works. You import Pygame, you initialize it, and initialization is very important because Pygame has abstraction to multiple different modules. This is how the hardware modules work, and you need to specify which module you're going to work with, so you need to have those initialization steps. You can't simply just use Pygame. And we need a canvas, we need a 2D Cartesian plane to draw something upon it. So we simply say display underscore set underscore mode and pass in those width and height. Then we have the main game loop, which is a continuous loop, which keeps on working until unless you have a specific condition which met. Here I've written if the event type is going to be pygame.quit, running is going to be false, and we're going to display.flip. So what does display.flip means? You have two things. You have either you flip or you blit. So you have two buffers. You have a queue of buffers, and buffers is going to be what's going to be interpreted on a screen. And your process is you have one buffer and the other buffer is just lying behind. If you flip it, the front buffer is just gone away, and the back buffer just take place of the front one. And we'll see what blit does in a bit. We can also do event handling. So be it your keyboard, be it your key press, be it your mouse change, or any kind of event handling, we can simply make use of those event handlers and do something out of it. And we can create our own objects. So Pygame is very flexible. You don't have to rely on images or pixel games out of the box. So if you even think of Pac-Man, the creatures are just filled up pixels on the canvas. You can do the same. You can draw your images. You can draw whatever you want to draw, and then make your own characters and fill up to the variables you're just calling your character. And so we import the game. We set up the display. We put up the caption. That's how you initialize some basic functions. And when you're working with some images, let's say you have a pygame.image.load, you pass in .png or a WebP files for faster processing because you want the file to be as small as possible. And you say hey, blit it. So what blit is you just want to have some specific things taking over, and you don't want to, you still want to keep the previous state, so a global state as it is. Similarly, you can use the mixer module and just add the sound, and you can add the .ogg file .ogg. It's a much better operation. They don't prefer using .wave. I only had .wave, so I just use .wave file. So you can use it, and you can just make it play. Event handling, as I said, if you quit it, you flip it, and everything like that. So again, this was supposed to be a video. So you can think of it as the green is the snake, and the red is the food. So we will be building a snake game in the next 10 minutes. And what happens is like the snake keeps on moving, and once it moves, once it eats that food, the size increases by 1 block. And the same snake game, it touches the walls of the canvas, it just like stops, or just like it touches itself, it just like breaks the loop. So how we're gonna build this game is, so first we're gonna be talking about like how Pygame, we're gonna build a game, and then we'll see like how we can then make use of pygbag and then make it work on the browsers. So you import the Pygame, you initialize it, you set the canvas, you also set .time.clock. So what does time.clock means is like you want to also control the frames of the game. Maybe you want something like a 60 frame per second game, or maybe 45, 120, everything, but you need to use a time module to clock everything so that like it knows when to refresh those rates. And we're just like defining a small rectangle as a character over here. Then we have the game loop, which detects the user inputs. If it's quit, so this is not the entire one, so it's just like showing you like if something happens, just like break it. Otherwise, keep increasing the speed of it. So keep moving on the x-axis and just like fill the space with black color, or add a character on top of on between, and flip the entire screen, make it go back to the initial one, and make it at a frame rate of 60 frames per second. And this is an extension of the same thing, like how we can make it work in an actual game loop. So we can also like add movements. So how we're going to be adding movements is we click the button. If it's the left button, we just like move it to the left-hand side. If you're at the right side, we just like move it to the right side. If it's an up button, we just like change the y coordinates accordingly. And we then blitz it. We say like, hey, just like put like a text on top of it and just like flip it. So this is what it says, like to blitz or to flip. So display.blit means you don't want that state to totally change. You still want that previous state to be as intact. But there's a new state coming in. Just like don't take away the buffers, but like keep it in the front and just like pop it out, just like your arrays or like the heaps are working. Then what you're going to do is like a flip, which takes care of your previous buffer. So you have 2 buffers. So this is the one, this is the second one. What blit does, it puts it in front, makes it visible, throw it out. You have a flip, it brings it here, but also throws it out. So the entire state changes. Collisions. So collisions is something which is like one of the main components of like when you're making games in Pygame. So there are like a couple of strategies which everyone has been using. The most common one is like AABB, circle circle, hash map, pixel perfect. So the example you're seeing here is called the AABB, axial aligned bounding box. So what happens is like checks for axis happening. So if they're like 2 rectangles and these two has only one axis, I mean, this is still colliding. Just imagine like they're like one square, another square, it's still here, so one axis is like matching. So you must have seen in games which you see in 2D Cartesian plane, where it says that, oh, it's too close. So that too close has been figured out with this collision, which is the axis aligned bounding box. And when 2 axes match together, it's a collision. So then you can have an event handler which does something out of it. Again, sorry for this. This is not, the snake is not moving. We're just like making use of the keyboards, left, right, and just like touching it, and the game is over. So brings it to pygbag. So pygbag is very similar to how Pyodide works. The only difference is like it doesn't have an abstraction directly make use of OnScripton to compile your Python code and makes it to WebAssembly. So it's not even a package manager, but it's something which you can say it bundles up all your code. So what it creates an event bundle. Eventually, it bundles up everything into a build file. And what happens next is, during this process, it's using OnScripton to convert your Python files to WebAssembly and creating those static HTML and JS files, in which you can simply run into your browser. And it can run natively on browsers. You have asset management, which is it creates a virtual file system. I mean, Pyodide also does the same. So if anyone here has worked with POSIX, kind of like POSIX kind of like file system, it creates a very similar file system which keeps store all the data, all the memory, and unless the file system has been refreshed or something like that. And it packages game assets, so everything will be packaged and will be used by the interpreted WebAssembly code eventually. It has an asynchronous adaptation. How it helps is like it makes sure like you are working, whatever you're building a game or something is in the alignment of the event loop of the browser. And it bridges the Python synchronous code to the, I mean, you can use asynchronous, but like it's not the native one. So with the browser's event-driven thing, so now what's happening is like your games are always going to be working. It's not going to be stopping. It's not going to be stalling. It's not going to be lagging. If you make sure like if it's using the proper event-driven approach. I'm going to skip this slide. Same thing, packaging tool, code translation happens under the hood. It does the asset packaging, creates those web app creation, creates those HTML and JavaScript, and it's very compatible with most of the browsers. And again, it's also running in the sandbox environment. So how do you adapt this Pygame to Pygbag? You don't have to do anything, because Pygbag works as a tool chain, and tool chain works apart from your code base. The only difference you need to do is like you just change your display.update to display.flip, because display.update is like pretty slow, and when you're working with a browser, it sometimes gets stuck. So it's preferred to use display.flip to change those buffers. You need to convert everything into an asynchronous operation, because browser won't understand what you're doing. Also, one more drawback is when you're working with Pyrdite gives you this operation of parallelly running everything. It makes kind of like a multi-threaded thing, but WebAssembly, the browser stops it. So still until today, we can't run we can't do like multi-threading on Pyrdite on the browsers. Still working on it. Still somehow something we'll figure out. And we also need to call asyncio.sleep, passing the 0 variable. Why is it necessary? Because we need to yield the control back to the browser. Because if you're running on something, we also need to give it back to the browser so that like the browser knows, oh, I need to stop in between. These stops are very fractional seconds, like momentarily these are happening. You won't see them, but like when you're seeing the animation, those can be super smooth. And yeah, if you have a non-blocking asynchronous approach, it will work. So what's happening here is we are creating a small Pygame approach, but using a Pygbag approach, which is converted the main function to asynchronous, calling displaying the 2D Cartesian plane. We pass the clock size so that like we can control the frames. Now we pass on those like characters. We call the gaming loop. We did like once it's said like quit, unless or until just like keep running, and that's it. This is just to show you like how we just like convert simple Pygame thing to Pygbag. This is just going to give you a small rectangle. Okay, the last thing is going to be how Pygbag works properly. So you have a Pygame code. You don't do anything else. You still write those Pygame code. Pygbag takes it and does under the hood, like uses unscriptum to convert those things into WebAssembly. But it also needs JavaScript to glue that code. Maybe you're doing some sort of like IO operations. It doesn't know the browser still needs to access those IO operations. It uses the JavaScript glue code and bundles them up. But at the same point, it might need some sort of images or music you must be asking for during the runtime of the game. So what Pygbag does, it directly gives you the asset packaging and sends it directly to the bundle which the Pygbag is creating. And eventually what it does is like it creates a wrapper on this bundle and sends it to the browser. So now what's happening is like entire game has been converted into a static thing, into a static wrapper, which you run on the browser or maybe call your Python server to run those HTML files. It'll start running that game on the browser. So the last thing is going to be, so I'll be real quick on this because I think we have 2 minutes left. Maybe you can get the slides later, maybe you can go through this. We'll have a code base for this. You can go and run this thing. We initialize the game, all the necessary imports, Pygame visualization, set the 2D Gaussian plane, said like, hey, the snake block size should be, total should be 20, the speed should be initially 10, which we're going to be increasing. Thus, how many blocks of snakes will be there? We just like create an empty list and start adding on top of it. We create the main loop. We're going to be passing on a lot of these event handlings of the snake. What happens if there's a key down? What happens if there's a key left? If there's a key left, we're going to go it back. We're going to change the x coordinate back. If it's a key right, we're going to work with the x coordinate, increment the size. If it's a key up, we're going to work with the y coordinates, not the x coordinates, and so on. And you just like keep persisting in the memory. collisions. So how we are doing is like we are doing multiple collisions check. We're checking like, hey, if it's the snake itself and touches its own body, that's a collision. We just like stop it. We say like, hey, game over, game is closed. We're also checking for food. If it's a food, we are incrementing the size of the snake because it's a good thing for the snake to have. And then we can also like draw different things, like we're drawing the snake, we're drawing the food objects, everything we're just like doing directly goes there and just like convert it to in pygbag. The only new thing when you're working with pygbag is make it asynchronous, call it until in async you run, call the function, and you're done, you're good to go. And if everything works correctly, just imagine this is the snake, you keep it moving and keep it down, and just like so. It happens. And yeah, that's pretty much it. And I think we are on time. So thank you so much for playing. Thank you so much for coming. And see you next time. But this was just the game was just an example of how you can actually make use of one of those applications. But with WebAssembly, this is like a super basic thing which we could cover in this time. But with WebAssembly, you can work with a lot of different things, from geospatial to anything you can think of. Alrighty, question time.
We are completely out of time. And
У нас
we have time for one question in English. Скиньтесь на камень ножницы, кто задает. Пожалуйста.
Maybe we'll start with them.
Давай. Все, Свет, сорян. Пожалуйста. Остальное в кулуарах.
We'll come to you next.
everything else behind.
We get this light on them. Sorry.
Thanks a lot for
Посмотрим на этот слайд.
I wanted to know your opinion on one matter. Do you think that Python can like rise and gain popularity and acknowledgement in web games? Because I think, at least that my like people that I talk to, they a lot of time they think that web games that should be written with JavaScript, and Pygame is just like little library which is used only for kids to learn Python. And actually a lot of time that's the case, because I actually also learned Python with Pygame. And I love Python. That's my preferred programming languages, and I also wanted to maybe sometime move to game dev, and I want to know, like, is it possible to be more popular?
Technically, yes, everything's possible. Computationally, it's going to be difficult. So you can even you can convert your Unity gaming engines to browsers now. That's still possible, but like, computationally, it's going to be too hard. You'll have to render just like the 2D games in Pygame. You can still make. I mean, Pygame was meant for 2D games. If you have played those games, which is like there's like a missile launcher and there's like invaders coming in. You just like keep moving. Those games are like made in Pygame. That's why Pygame was very interesting probably in the 2000s. Now you can also make 3D games, but the only problem is like there's no specific STL directive which can be just like used to make those things. You need to create your own wrapper on top of it, because eventually down the line it's giving you an abstraction OpenGL, and now you just have to, because everything on the web, even 3JS and everything is like working on those GL libraries. So yes, it is possible. Secondly, if you are using some other gaming engines like C#, you can simply use OnScriptum and convert them into the browser. So yeah, that's also possible. But for the entire web, I'm not sure like how much adoption it can be, because if you're already working with JavaScript, you don't need WebAssembly, or maybe you can to speed up those like binary instructions format. But if you're someone like coming from a different background, let's say Java or something, definitely you should be using WebAssembly as soon as possible, because then you can simply convert those desktop applications to your web. And that's not just for the games. Even if you're working on something like a desktop application, like Electron kind of apps, like Tauri is like one of the one which is using Rust these days, and that can be also like converted into WebAssembly. They are currently working on, if you go to the issues page, they are currently working on like a migration for this thing. So yeah, to answer your question, yes, it is possible. And you should give it a try because Pygame is like a direct abstraction. Pygbag is a direct abstraction meant for Pygame. And was not called Pygbag, it was something called Pygame WASM SDK, but then it was named as Pygbag. But yeah, for other libraries, it's also like possible.
Thank you so much.
The time, unfortunately, is up. So we have more questions,
Sure.
and the people will, and you have to take the questions personally, if you don't mind.
No, not an
The
issue.
sun is shining. We have enough.
Not an issue.
enough
Not an
space.
issue.
And now you have to choose between this speaker and other speakers who asked questions. Who gets the book?
So maybe I'll just like take a very quick question.
I say we give them both books. What do you say?
So they'll need only 2 questions?
I counted. We have enough books. Yes. I personally...
Are you sure like there's no other question? Okay.
Да, девчонки, да, выходите, пожалуйста, возьмите книжки.
Please come up here on the stage. Ladies, please feel free to ask further questions on the sidelines of the meeting. A big thanks to our speaker and to the interpreter.
Absolutely.
Please.
Thank you so much.
И следующий батл, друзья, здесь через 1 минуту. Будем...
In exactly 1 minute, we proceed with a battle comparing DI tools. Stay tuned.